Dear students, in the previous class we have discussed the paired t-test procedure. Paired t-test procedure to compare two population means using paired samples. The assumption for the paired t-test procedure is that the paired difference variable d, is approximately normally distributed, or we will have a large sample size. Either the D is normally distributed or we have a large sample size. Now, for a moderate or a small sample size, when the distribution of the paired difference D is far from normal, then paired T is not appropriate. Paired T is not appropriate. So in that case, we use the non-parametric procedure. We have introduced non-parametric procedure earlier for testing the significance of one mean if the population is symmetric, not normal. That is the Wilcoxon signed rank test. We have also considered how to test the difference between two means or medians when the distributions are identical, not normal. That is Mark-Whitney test. Now, one non-parametric test which is used to test the significance in the case of paired samples is the sign test. One test used for testing the difference between two populations, two paired populations when they are paired, is the sign test. But unlike the sign test, we use a different test, that is the Wilcoxon paired test. We use the non-parametric signed rank test. Wilcoxon signed rank test. When we are using paired samples and the paired difference is not assumed to be normal, or if sample size is small or moderate. One test is the sign test, the non-parametric test, to compare two populations. So what we consider is a more powerful test, the Wilcoxon signed rank test. And what is the advantage of Wilcoxon signed rank test over the sign test is that in the sign test we consider only the signs, positive and negative, between the difference between paired observations. But in the Wilcoxon test, we take into account the magnitudes. We take into account the magnitudes of the difference between paired values, the magnitudes, not merely the signs. So, and how the magnitudes are considered? The test does so by considering the rank of the differences. In the Wilcoxon signed rank test, we rank the differences between paired observations rather than taking the minus and plus differences. So, the magnitudes are involved here because we are giving ranks to the magnitudes. So, it is more efficient than the sign test. Wilcoxon's signed rank test is more efficient than the sign test as the differences are quantified rather than given positive or negative signs. Also, the Wilcoxon procedure is adapted for testing whether the mean or median of a single population equals a particular value that we have discussed in the beginning. So, Wilcoxon test is used to test the significance of a single population. Also, it is used to test the difference in mean, median or simply distributions which are paired. So, it is a non-parametric alternative to the paired t-test. So, if the distribution of paired differences are symmetric, if the distribution of the paired differences are symmetric, need not be normal. D is symmetric, need not be normal. We can perform hypothesis tests to compare the means applying Wilcoxon signed rank test. So, the only requirement is the paired difference is symmetric. Now, the Wilcoxon signed rank test is called paired Wilcoxon signed rank test. Paired Wilcoxon signed rank test. So, let me tell you, Wilcoxon signed rank test is used to test the significance of a single mean, whether it is different from a hypothesized value. Compare the difference between means if the samples are paired or population is paired. If you want to compare means or medians or two independently distributed populations, then you have to use Mann-Whitney test, also known as Wilcoxon Mann-Whitney test. So, let me explain the procedures. For applying the paired Wilcoxon signed rank test, we assume that the assumptions are: assumption number 1, simple random paired samples. Second assumption is symmetric differences, that is, paired differences or the paired difference variable has symmetric distribution, that is, one half of the distribution is the mirror image of the other half, and the measurement scale at least will be ordinal or at least interval. Now, let me say what are the steps. H0 is mu1 is equal to mu2. We can test this using median also. H1, mu1 not equal to mu2, mu1 less than mu2 or mu1 greater than mu2. Two-tailed, left-tailed and right-tailed. Then, that is the first step. The second step is fix the value of alpha. the significance level. Usually we take it as 0.05 or 5% level. The third, compute the value of W, as we have explained earlier. Then in the fourth step, what we do is the critical values are W1 minus alpha by 2 to W alpha by 2 for a two-tailed test, then W1 minus alpha for left tail, W alpha for a right tail. These critical values are available in the table, or if you are not interested in the critical values, you can go for the p values, and the computer, the software will give you these values. Then for a left-tailed test or a two-tailed test, W1 minus alpha is equal to n into n1 plus n into n plus 1 by 2 minus WA, like that we have discussed earlier. So the procedure is this: for a two-tailed test, for a left-tailed test, for a right-tailed test, compare the critical values from the value of W obtained from the sample. Now, as an example, a random sample of 10 married couple. It's a simple example taken, and ages are given. At alpha is equal to 5% level, we want to test whether there is a difference in the average age of husbands and wives. So age of husband is given, age of wife is given, say 59, 53, etc. D is taken 6, absolute value of D is taken 6 here. Then you rank the differences, rank the absolute values, and give the signed rank, as we have done earlier. Differences, absolute value, rank the differences, then sign the rank. Then our H0 is mu1 is equal to mu2 tested against mu1 not equal to mu2 here. Mu1 not equal to mu2. We fix alpha at 5%, and W is, as we have discussed earlier, sum of positive ranks. In this case, it is 46.5. And at a 5% level of significance, the critical values are, that is W alpha by 2 and W1 minus alpha by 2 are 8 and 46.5. 8 is the sum of positive signs, 46.5. 8 is calculated. So what is the value obtained from the sample? It is 47. So we reject the null hypothesis that mu1 is equal to mu2, as the value of the test statistics is in the critical region. This example will be discussed in the context of the software, and all these examples will be repeated when I demonstrate these procedures using Megastat. So this is Wilcoxon paired rank sign test, a non-parametric alternative to paired t-test.